chart. Okay. So we will be comparing univariate distribution. That includes back-to-back stem plots. So when we do stem plots, stem and leaf plots, we don't just have to do it branching off to the right and on one side. We can also do it to the left side as well. So it can include both sides. And parallel box plots, we don't just have to use one box plot, we can do multiple box plots, okay? And I believe we have done questions on this. Well, not yet, but we may have come across one with a parallel box plot. I just remember seeing one. Nope, who am I kidding? Maybe it was exam 2. Oh yeah, there we go. So can you guys see there? That's a parallel. I know it's not horizontal, it's vertical in this particular case, but that's fine too. Like you can see the values going up instead of going across from left to right. But you can see that there's a comparison there of 3 box plots. They're all parallel with each other. Yeah, parallel means that they run in the same direction. Okay, side by side. That's what parallel means. Okay. Hi, Huda. I'll just mark you here.
Hi, sir.
Hello. Frank Walker from National Tiles. I don't know if you guys used to hear that on the radio.
Bro, I used to impersonate him in year 6. What do you mean?
Oh, good. All right. Ongoing. Just a reminder, if anyone hasn't completed their pivot survey yet, please do so. I think I've got like most of the people in our class. It's just a couple of people left over. So yeah. Again, textbooks there, back of the book. All right. Now, let us head over to the iPad and we'll start getting onto this. Yeah. Share. All right, can you guys see the screen?
Yeah.
Yeah. Excuse me for a second. I've just put a block over it. All right. There we go. All right. So when we compare back-to-back stem and leaf plots and box plots, we're comparing. So we need to use this. We need to focus on using language that compares, right? More than, less than, the same, stuff like that. Yeah. And as we go through examples, you'll start to see more examples, so you get a better picture or a better idea of what goes on. Okay. So here you can see that what they're doing is that they're comparing the height of people in the basketball team and versus people in the gymnastics team as well. Like, would they be the same height? Would one be higher? Would one be shorter? Stuff like that. Other things you can compare as well is like, say, for example, temperatures in March versus in Sydney in March. Big hint. In fact, Okay, and test scores. You can also compare test scores as well. So it's like, oh, whose class did better? So you can start to think about whose class did better or who did, if you were in the average of your class as well, stuff like that. So it says here, in each of the examples, we can actually identify two variables. One is a numerical and the other is a categorical, all right? So here it says maximum daily temperatures, right? And maximum daily temperatures, those are numbers, yeah? Those are numbers. But when we start thinking about in Melbourne and in March, aren't they different categories? Okay. So those are two categories there. So you can start to get this idea of comparing back to back or parallel, okay? Let's see here. Probably best if we just jump to an example here. So we can analyze, we'll have a look at how they do the question first, so we can analyze what kind of language they use, how they compare it, and what the standard response is as well. And we might also go to a year 12 question and analyze what kind of language they use to compare parallel plots as well. So I'm just thinking if we could go back to that body mass index one. And then we might have a look at that one together. Okay. So here it says, the following back-to-back stem plot displays the distribution of life expectancies. We've got a couple of questions popping up in the chat about the SAC or the hurdle task for univariate data. If we have a look at our unit timeline here, we're on 2i already, right? So we're very close.
Can't see, it's a black border. We can't see, there's the border thing that blocks it.
Whoops, my bad. There it is. We're already on 2i today. Thursday, we'll do 2J, which is statistical investigator, which is like, well, it's just an extension. You're putting all together all your skills, and that's similar. There's only one question in exercise 2J. It's basically revision of everything that you've learned, and it's learning how to sift through data and apply your skills. So 2J, like, you can spend time doing that after this lesson anyway, because it's like chapter review, okay? And then yes, do your chapter review. I'm thinking this Friday. The way that we're going to do the SAC is we're going to, instead of doing it on Education Perfect, I had like doing it on Education Perfect is better for lower year levels, like up to year 10. But once you get to year 11 and year 12, it's better to get you guys to start practice writing on paper because in year 12, you guys have to write on paper anyway. Okay. So what I'm going to get you to do is I'm going to send out like a document, email a document to you guys about the questions and everything. But then what we're going to do is we're going to get you to write out your answers. Once you're done, then you submit, you take a photo and then you submit it at the end of the class. If you don't submit it at the end of the class and you submit it to the end at the end of the day, then that means it's unfair because you're spending more time to do the SAC than everyone else. So if you don't know how to scan a document and then email it, then I suggest that you learn how to do so. Ask a mate, figure it out, because I'm sure you've done it in other subjects by now. Does anyone not know how to scan or take photos of their work and then upload it? Can I just get a thumbs up that if you do know how to do it? Arafat, Maddie, Adele? Okay. What about you, Arafat? And what about yourself, Adele? Arafat, sick. And Adele, I'm pretty sure like Adele sent like stuff to me as well. Okay, awesome. So exercise 2I here. I'll just scroll down so you guys will see what exercise 2J is about. There's only one question there before you're done. Okay, so just one question there. And you can see there's a lot of categories or a lot of ideas, but then the questions will get you to compare, say, for example, 2010 fathers versus fathers in 1970 or something like that. Okay. So they'll pick and mix and match different categories and then say like, okay, what do you notice about like the age of the parents? Okay. Was it a lot older or was it a lot younger? Stuff like that. And really, exercise 2I leads us into that. So let's have a look at what they compare here. They're comparing life expectancies, okay? So how long a person lives for. And you can also see it's for males and it's in years. So you can also kind of capture that from the back-to-back stem and leaf plot. Notice the feature that they have. They have a title, which means that when you do your work and you draw up a stem and leaf plot, it's also probably a good idea to put a title as well, yeah? Now you can see here that 1970 and 2010, they're different ideas, aren't they? Now, we can see a few things come together here. When we talk about life expectancies and with males in years, what kind of data are we talking about? Numerical or categorical? Let's start off with Zach today. What do you reckon, bro? Like, is
Numerical?
it numerical? Correct, because we've got numbers in years, yeah?
Yeah.
And what about this idea of years in years of 1970 and 2010? I'll pick someone else. Adele, are you there? I'm gonna check. Or not. Arafat? What are your thoughts, bro? Like on these two ideas here. Like they're one group, right? Let's walk through this and we'll have a chat about it together. Do you reckon it's numerical? So do you reckon the years there are in like have numbers? Or do you reckon they're categories? Or are you still sleeping? Legend. Haram.
Weapon?
Arafat sleeping. Oi. Gotta remember that I'm recording, so Arafat.
Maria,
Uh-oh. Gonna put you in the
Waiting room.
no, I know what I'll do. I'll put it in the breakout room. I'll make a oh wait, I can't make a oh wait, I can. Hello. Assign manually. Yay. Oh no, but they gotta join. Yeah. Adele, Arafat. Anyone else? Fight me. All right, Gordon.
Yeah, I'm here.
Sick. Thanks. What do you reckon? Do you reckon these two ideas here are categorical or numerical?
I would say they're numerical because they're years.
They're years, but how many years are we comparing? That was a bit of a tricky one, yeah? Like, how many years are we comparing? Like, let's say this was cars, for example, right? Or let's say, instead of talking about years, let's say we're talking about males who lived in Broadmeadows versus like males who lived in Sydney or something, like their life expectancy. Is that still numerical?
No, that turns into categorical.
Right. So in this particular case here, and correct, Zach, you typed in the chat as well. Thank you. You can see that if we remove those and we consider 1970 and 2010, those are technically categorical, yeah? I know it doesn't seem like it's categorical, but they're different years. And so we can categorize them as one as 1970 and one as 2010. But I'm not, actually, I will be asking something like that, but it won't be as something as obscure as this, okay? So categorical right there. All right. In this situation, life expectancy is the numerical value. Oh, year which takes the values 1970 and 2010 is the categorical value. Oh, whoops. If only we read a bit more, hey? Now let's have a look here, shall we? You can see they've displayed all the information and they've done the back-to-back stem and leaf plot. What kind of features can you see on here? Let's just do a quick brainstorm exercise. What do you see? I know you can type in the chat.
The medium for both of the years.
Sorry?
The medium.
Yep. They've definitely got the median for both of the years. The capital M there is the median. Nice. What else? Key and legend. Yes, fantastic. Notice a key and a legend here. That's very small, right? I'd write that probably over, I'd probably write this somewhere over here, to be honest. I'll probably write it off onto the side. Ta-da! So if you write the legend off on the side, then you can see the key a bit more clearly. It's more in your face, yeah? I have some people saying IQR for both years. Yeah. The interquartile range for both years. Fantastic. So you can see the interquartile range for the life expectancy for males in 1970 is 12.5 years. And for this one here, it's 8 years in 2010. Okay. Got someone saying the data for both categories. So this is one category, yes. 1970 and 2010 are separate categories. And you can see here, yes, this is the data that's been collected, okay? So here you can see, is this 83 here? Is this 83?
No.
Nope, it's 38, okay? 52, 54, 59, 60, 61, 67, 67, 68, so on and so forth. Here, 58, 59. What do you notice? What can you comment about this? Like, can you just make a random comment about it? Like, I want to see what you are able to gather so far from this. Think about life expectancy, yeah? Do you reckon people would have lived longer back then, or do you reckon people would have lived longer now? And back it up with some evidence. What are your thoughts?
They live longer now in 2010
Yeah. What kind of gives you the idea there?
because there's like on the larger scale, like 70 and 80, there's way more numbers than in 1970 compared to 1970.
Right. Okay. Yep. So you're talking about you're focusing on this area here, right? What do we call that in data analysis? Is it shape? The center? The center is the same as the location, or is it the spread?
The shape of it, isn't it that the spread of the data?
The shape and the spread,
I don't
they're
know.
different things, yeah? So someone's saying spread in the chat.
Isn't it
Well,
location?
okay, so we've got spread, location, and Huda, I think you also said the shape as well, yeah? So we've got 3 different answers here. It's good variation, yeah? It's good variety.
It's location, trust.
Okay, explain why and support. You got to support your answers. You got to back it up.
All right. Well, comparing it to the 1970s, the location in which the life expectancy is at its highest is in the 60s, like the age 60s. Whereas if you compare it to 2010s, it's in the 70s.
All right. Can we explain that in a more concise way?
The modal data is in the 70s and 2010. I don't know.
What kind of information do we have that includes numbers? Like that's already summarized some stuff for us.
The mean?
Do we have the mean or is it the median?
Oh wait, whoops.
What do we have?
The median,
The median and
the IQR.
Interquartile range.
okay, so we got to know how to use these ideas, yeah? When we talk about the median, what are we talking about?
The average. No, the
So
middle.
we
Like,
Median
the
is the
middle.
middle number.
We
The middle
learned
number.
this. Yeah, it's the middle number, correct. And what is it a measure of? Remember in this exercise here, 2G, summarizing data. What did the median talk about? Now we could flick through these individually, yeah? But didn't we write a summary at the end of this exercise? Scroll down to it. Am I the only one who remembers where I write my notes? Yes, it is talking about the middle number, but it's talking about what's the overall idea? The location, right? So the location here is also the same as the center. In year 12, I think you'll hear the word center more, and Mr. Narayan helped me correct this. So he's like, when you say, instead of saying like just location, say the center as well. Okay, so I've got some people typing in the chat here, some summaries that they've kind of realized or pulled out. It says here, the average life expectancy in 2010 is 9 years higher than it is in 1970. That's actually fantastic. Okay, because you've included a comparison. You've also let us know how much difference there is as well. I've got another one here. The life expectancy compared to the 1970s to 2010 has increased. According to the stem and leaf plot, the starting value in which the life expectancy starts at is 58, right? Whereas in 1970, the starting value was 38. Okay, so you can see that here. The starting value for the people in 2010 is 58. The starting value is 38. Now, are we talking about starting value here? Is that when they're born?
No, starting value as in where the life expectancy ends.
Isn't this the ending value? If you were to talk about starting and ending, 74 and
I'm not
80.
talking about the thing. I'm talking about their life log. Anyway,
Yeah.
no, where they
Perhaps use
start
different
recording the
language
values.
then. Right? Instead of saying starting value, the lowest life expectancy is 38 for males in 1970. Notice how I didn't say starting value. I said the lowest life expectancy. So it's just tweaking the language there a bit. We also consider the location of the data, where 2010 is higher in values, whereas 1970 is lower in value. Okay, so they're fantastic observations there. I've got 2 in, right? But I noticed that in both of those summaries there, no one included values like this here. No one included these values, these summarized values here. The one how it said the average life expectancy in 2010 is 9 years higher than it is in 1970. I agree, right? But how do I know? Like, 9 years from where to where? So we need to specify. If you don't include these numbers, now I've mentioned this in our earlier exercises, when you write a statement, you have to include not just your observations and comparisons, you also have to include the numbers. You have to include the evidence. Okay, so I've got a recorrection here. Someone sent through a recorrection of their answer, and I think it's much better now. So let's have a look here. I'm gonna put it up to there. I'm gonna do a bit of typing, yeah. So we've got one idea. It said the average life expectancy. Ooh, oif. Now, when we say average, what is the M value measuring again? Is it the average or is it the median? What does that capital M there represent?
Median.
So why are we saying average? Isn't an average a different idea?
Yeah, who said average?
Right. So we should change that idea of average to median, first of all. Oops, expectation. Expectancy in 2010 is 76 years old, comma, which is 9 years higher or longer? Which word should we use, higher or longer? You got to think about using correct language as well, yeah? All right. 9 years longer than the life expectancy in 1970, where the median is equal to only 67 years. Have I included in this example of this analysis here, of this first idea, we've only compared the median, yeah? Have we included all of the ideas necessary?
No.
What's missing?
The interquartile range.
Hmm?
The IQR interquartile range.
We'll get onto the IQR, but not yet. We're talking about the median life expectancy. So is it just the median life expectancy? Because if you talk about median life expectancy, who do you think of?
Old people.
Old people. What kind of gender?
Oh, male.
Right. So when you just say life expectancy, how do I know which gender? Have you specified? You have to include male. Yes. So life expectancies of males in 2010 is 76 years longer. Is 76 years old, which is 9 years longer, yikes, than the life expectancy of males in 1970. And then you write there, the median is 67 years. So what have we just done here? We've done a comparison for the center or the location. Okay. Notice how we're doing this very methodically. We're going through one idea at a time. Can I just get a thumbs up or thumbs down for interpreting this? Does it make sense? Does it not make sense? Okay. Notice. Awesome. Which word in here is the comparative word? Which one's the comparative word?
There's no comparative word.
There's no comparative word?
Wait.
Which? Like in between.
Kind of.
Is which comparing two things?
No.
Not really. Continue having a then. Is it just the word then? Okay. Correct. Someone wrote 9 years longer than. That's our comparative phrase, right? So this is what's comparing. But I'm going to dig deeper here and the comparative language here is longer than. Can you see that? More specifically, it's the idea that it's longer than. That's the comparative language that's been used. When you're comparing, am I shorter than or am I taller than? Am I longer than or am I shorter than? Right? Is it more or is it less? So this is something that you need to include in your comparisons. Is it more narrow or is it more wide? Sorry, is it more narrow, or is it more wide? If we talk about spread. Okay. So we've tackled the idea of center. Can we talk about the spread? What idea would we look at for spread? Type it in the chat. What idea would we look at for spread? Spread is how spread out the data is, which means we should look at the range. Okay. Someone also said IQR, range, and standard deviation. So you're on the right track. What do we have? Now let's go back to the question and see what do we have? Someone just said the range. Have they already given us some values? Okay, excellent. Gordon, you said we have the IQR. So let's use this and we'll do a comparative analysis on these two ideas here, these two numbers, right? What does it mean if it's the interquartile range is 8 years versus the interquartile range here is 12.5 years? What does that even mean? Do you remember what the IQR tells us about? Can you scroll up in your notes?
3 take away Q1.
That's the formula, right? But I'm talking about the concept here. What does it tell us? What is the idea? I need you to scroll back up to the notes. So standard deviation there, nope. What does the interquartile range tell us? So someone in the chat said how far apart the lowest and the highest measurements are. Is that the highest and is that the lowest measurement? Or do we have a higher and a lower one?
You have a higher and a lower one.
You do have the higher and the lower, but that if you do maximum minus minimum, then that gives you the range, not the interquartile range. True?
Mm.
True. Okay. So can you guys read on the page here, this section? Okay. Yes, someone already said the Q3 minus Q1. That's the formula. I want the idea. Okay. Yes, the idea is that it's the middle 50%. This still tells us the spread, yeah? It tells us how far it's spreading, but it's the middle 50% here. So let's go down. This information tells us that the IQR, or the middle 50%, so say for example from here to here, like somewhere from here to here, is 12.5 years, whereas this one is like, say for example, Q3, Q1, the spread is only 8 years. So what does this tell us about people's life expectancies? What does it tell us about how long people live? Seems a bit obscure, yeah? Does anyone, yeah, go Matt, give it a try.
The difference of male life expectancy between different countries is less than what it used to be.
Different countries?
But is it countries? I didn't wait. Yeah, it's several countries. Yeah, in the countries that have been recorded.
Where does it say that?
It says it at the top. In several countries in the years 1970 and 2010.
Right. Are we comparing 1970 and 2010 though?
Yeah, the IQR.
The life expectancy. So I've got a suggestion here in the chat how it says, with that idea, Matt, it was like, I think you were supposed to compare 1970 with 2010 rather than comparing different countries. Because we don't know where these people are from. If you want to compare countries, then we actually have to figure out where each of these people are from. Does that make sense? But we don't know where they're from.
Yeah.
So that's why we're not trying to compare the countries. We don't care about the countries. We just care about the years where they're from, when they're from. Okay. I've got a suggestion in the chat here. It says the male life expectancy in 2010. Okay, so we're looking over here. Is 4.5 shorter than the life, 4.5 years shorter than the life expectancy of the males in 1970. So what this person did was found the difference between 12.5 and 8. But is that what we do with spread? Is that how we compare spread? I'll give you an example of how we do it, yeah? When we're comparing spread here with the interquartile range, okay? We are comparing how much they vary, okay? So when we talk about spread, we talk about narrow or wide, okay? I'll write this one about spread. Notice how I'm putting down the idea as well. 12.5 years. Is wider than. Okay. I'm going to take both of these ideas and we're going to compare our ones with the one that they provided. Okay. So what I want you to realize here is that the comparative language that we use when we talk about spread is talking about wider than or narrow, more narrow or more wide. Because this 12.5 years means that there's a wider spread or a larger spread. Okay. Compared to the spread in 2010 of males' life expectancy in 2010. So what does that mean though? What does that mean? Well, it means that you live longer. If you're in 2010, you tend to live longer, or everyone lives longer, right? Whereas in 1970, only a few would live longer and a few would live less. And then you've got like a couple in between. So it's very inconsistent. That's what it means. So there's two ideas here that I've used for comparative language in here: more wide and more consistent with their age. So that's what we're comparing when we talk about spread. Okay, is it more consistent or is it less consistent? Is it wider than or is it more narrow than? And notice how I include numbers as well. Yeah, I included those values of IQI as 12.5 and IQI as 8 years. So see how when we compare the center, it's different to how we compare the spread, just by slightness in language and the ideas. Yeah. Let's have a look at how they put their answers. They said the median life expectancy of males in 2010 was 9 years higher. 9 years higher. Okay, it should be 9 years longer than in 1970. The spread of the life expectancies in males was different. So that's their comparative language, right? That's their comparative language there. Was different. And this one here is longer or higher than. Okay, there's the comparative language there. In conclusion, the median life expectancies for these countries has increased over the last 40 years. And the variability of life expectancies has decreased. So what does it mean by variability? That's talking about the center or spread? Spread. Okay. So one thing we've missed from here then is an overall comparison between the two. Okay. So maybe to keep it shorter for us, we don't need to include this last section here. We can talk about that it's wider than, okay? So there's more variability. In fact, I might also include in here and just do the interpretation directly. This means that the variability has decreased over the 40 years. Whoops. Where did it jump to? Okay. So we'll make sure to use words like variability when it comes to spread. Okay, and we'll also be sure to use the idea that it's decreased or if it's increased compared to the two different groups. Okay. For center here as well, we might also include that summary in there as well. So if you want to think about this in a logical way, or if you want to interpret it, yikes. That's messy. Oh goodness, I'll fix that up. So what we've done here is instead of writing three things, right? One about comparing, one about center, one about spread, and then a conclusion. We can write our comparison of center and then write our conclusion there in the last sentence. And then we can write one comparison about spread and then write the conclusion there as well. Okay. Can I just get a show of hands if this is like, put a party face if it's kind of like, or put a thumbs up or a thumbs down, just so I know. Okay, cool. I'll see you within the last 5 minutes here, just to summarize. We'll do one for this one here, just so you can see how I do it for. And we might spend another lesson on this actually in on Thursday before our hurdle task. So just quickly looking at this here, I can see my median is 65. And this one here is roughly 70 something, 71, 72, I'll say 72. Now let's have a look at the ideas here. The parallel box plots display the distribution of pulse rates in beats per minute for a group of female students and a group of male students. Instantly, you can see numerical and categorical. Okay, so here it says, use the information in the box plots to write a report comparing distributions in terms of center, spread, and outliers. Okay, we also have to look at outliers now as well when we look at box plots. So I'm just going to quickly do it here for you guys, and I'll show you in handwriting as well. I'm going to break it out into one with center. Let's focus on the center first. I'll say female pulse rates I'm just going to say here median equals to 72 beats per minute. Is how much is the difference here? That's 7 beats per minute higher. So notice I said higher than in this case, not longer than, because of the idea that we're talking about the pulse rate than the male pulse rates, which has a median of 65 beats per minute. And what does this mean? It just means that females generally have a higher pulse rate than males. So comparison, conclusion. That's one idea down. The second idea is spread. Spread, well, we know parallel box plots, we can calculate the IQR. So the IQR here is 10 from 60 to 70, whereas the IQR for females here, it's 65, and up here, let's say that's 80. So you can see the IQR for females is 15. So who has a wider spread?
Females.
Female pulse rates with an IQR of 15 beats per minute. I'm just going to write BPM for beats per minute. You guys have to go now, don't you? It's 10 o'clock.
Yeah.
I'll finish this off and I'll email it to you guys. Have a read through. Make sure you write down notes for it. Yeah. Cool.
Okay.
Yeah. Thank you,
All
sir.
right.
Have a good day.
See ya.
Bye.
Bye-bye.
Bye,
Alright,
sir. Have a nice
see you
day.
later.
By the way, class at the end of today as well, if you're interested in coming. Bye.
Bye, sir.